This lesson we're talking about parallel and perpendicular lines. So let's take a look at some ways we can figure out whether they're parallel or perpendicular. Well, obviously for parallel, if we graph them and then they never meet, then we know they're parallel. But we can also look at their slopes. If the slopes are the same, then we know that the lines are parallel, which makes sense because if their slopes are different, they're going to cross eventually. Non-vertical perpendicular lines have slopes that are negative reciprocals. What does that mean? Well, if one has a slope of negative 1/2, the other will have the slope of 2/1, and we negate the negative, which makes it a positive. So they have opposite signs, which again makes sense because if I'm talking about perpendicular lines, one guy is going to have a positive slope and the other guy is going to have a negative in order to cross like that. And perpendicular, of course, means that the lines meet at a right angle. So number 1, determine whether the distinct lines through each pair of points are parallel, perpendicular, or neither. We're going to use the formula to find the slope of each line. So line number 1 goes through these 2 points, and line number 2 goes through these 2 points. So let's do line number 1's slope. So the slope is the difference of the y's, so it'll be 2 take away 1 over 9 take away 3. So it'll be 1 over 6. Now let's talk line 2. Okay, the slope of line 2 is 10 take away 9, difference of the y's, 7 take away 1, so it'll be 1 over 6. So these two lines, since they have the exact same slope, the lines are parallel. Okay, now let's do the next example. So line 1 goes through these points. Let's do a little m sub 1 indicating we're getting the slope of the first line. So it's going to be 5 take away 2 over 3 take away 1, which is equal to 3 over 2. So that's the slope of the first line. The slope of the second line is equal to 7 take away 9 over negative 1 take away negative 4. So I wanted to do one where you had a lot of negatives in it so you can make sure that you're subtracting correctly. 7 take away 9 is a negative 2. Negative 1 plus 4, right? I just might as well write that. Negative 2 over 3. So if we look at these two slopes, they're negative reciprocals. We have 3 halves. We flip and negate. So these lines are perpendicular. Now we're going to determine whether they're parallel perpendicular lines using the equation. So the first thing we want to do is pop them both into slope-intercept form. Well, what is slope-intercept form? Let's recall y is equal to mx plus b, where m is the slope, which is what we want to hone in on that. Want to hone in. So let's take a look at this part A here. First of all, this line, the second line, has a slope that we can read off of negative 2 immediately. So we're all good with that. And we can graph it, and we're really psyched. The first line, not so much. So let's get this line into slope-intercept form. I'm going to move this x over to the other side as a negative x. Tuck them in, remember? And then I'm going to divide everything through by -2. And I'm going to put a -1 in front of the x just so that I remember. So y is equal to negative divided by negative is a positive. Negative divided by negative is a positive. Okay, so let's take a look at this. Well, the slope of this dude is 1/2. Well, think about this slope is -2/1. So they're negative reciprocals. So these lines are perpendicular. Okay, next, let's take a look at these guys. Now, if I look at it, none of them are in slope-intercept form. So let's take a look at B. Now, if I think about it, this is a -y here. So I'll move him over to the other side. So I'll get 3x is equal to 6 plus y. And then I'll move the 6 over. So 3x take away 6 is equal to y, or y is equal to 3x take away 6. So the slope of line 1 is 3. Let's take a look at this dude over here. This one is almost in slope-intercept form. I'm going to stick a -1 in front of that x. So y is equal to -1/3 x plus 1/3. So if I look, the slope of this guy is -1/3. Oh, we're psyched because here's this guy, here's this guy. They're negative reciprocals. So the lines, again, are perpendicular. Good? Yay. Next. All right, let's talk vertical and horizontal lines. So we want to find an equation of a line parallel to the line x is equal to 5 through the point 3, 4. So first I'm going to graph the given line x is equal to 5. And again, we can use a table, or if you're getting good at it, you can just graph it. X is always 5. Y is whatever it wants to be. So 5, 0. This is my cute little x-axis, my little y-axis. 5, 0 is right here. 5, 1 is right here. Oh, we have a nice vertical line. Perfect. And then I'm going to graph the given point, 3, 4. There he is. He's 3, 4. And I'm going to draw a line parallel to the line x is equal to 5. Again, this is the line x equals 5. Now I'm going to draw a line parallel to it, so I'm going to, and it has to go through the point that I just graphed. There it is. So what's the equation of that line that I just drew? Well, along every single point on this line, x is equal to 3. So my answer is x is equal to 3. So x is equal to 3 is a line parallel to the given line x is equal to 5. I have a new line. There's a new line in town. There he is. Okay. Now let's do the same thing except finding a line perpendicular. Same point, same everything. So let's rock on and graph. X is equal to 5. There he is. Took me a minute to get everything organized. 1, 2, 3, 4, 5. Here's my cute little x-axis, my cute little y-axis. X is equal to 5. The point 3, 4. 1, 2, 3. 1, 2, 3, 4. Good. Now we're going to draw a line perpendicular. So that's this way. Yay, there he is. Now we're going to get that equation. So what is the equation? Well, every single point along this line, y is equal to 4. So there we have it. There's my new line. And this line is perpendicular to the given line, passing through the point 3, 4. Now you're ready to do the My Math Lab assignment associated with this lesson.